All right. So today we're going to be looking at Kirchoff laws. Kirchoff has two laws: the Kirchoff current law and the Kirchoff voltage law. And the current law is also known as the junction law. I will explain why it is called the junction law. And the voltage law is also known as the loop law. We'll be explaining why it is also called the loop law in this video, because they are very important in solving questions like this. Now this is an electric circuit. Everything that we have here, right, is an electric circuit. And now in this circuit, now the question is that we should find the current passing through each resistor, right? So this 5 ohms resistor, this 3 ohms resistor, this 2 ohms resistor, we have to find the current that is flowing through each of these resistors, right? So we're looking for 3 currents, but we do not have any current being given. When we have something like this, we have to employ Kirchoff's laws. Now the current law tells us that the total current that is flowing into a junction is equal to the total current that is flowing out of that junction. So now if you look at this here, this point here that we have here is a junction. Let me use another color so that this point here is a junction, right? This point is a junction, so that's why it's important. So the law tells us that the total current that is flowing into this junction is equal to the total current that is flowing out of the junction, right? And now from this my lines, now you can see that the current is flowing in this direction and it's flowing out like this, and it's also flowing out towards this direction. So now what we are saying here is that first of all we have to get the direction of the current flow. Now to get the direction of the current flow, it's very, very simple. So now current flows from positive to negative. From positive to negative. It is electrons. Electron now is like the real life application. Now electrons flows from negative to positive, right? But when we are talking about current flows from positive to negative. But regardless of the one that you use, you will still get a correct answer numerically. The only difference will be the sign, right? And once the sign is different, then you just have to change the sign. But ideally, this is what we are to go with. Current flow from positive to negative. All right, let me clean this. Sorry. Okay, let me just rewrite this back. We have 5 ohms here. So now whenever you see a circuit like this, now this 12 volts is representing the EMF, then these ones are representing resistors can either be like this or they are like this. So whichever one you see it as, they are both resistors, while this one represents EMF here, right? So now for this one, now the longer side, right, the longer side tells us that this side is positive, while this shorter side tells us that this side is negative, right? And now since we already said that for current flows from positive to negative, so it means that the direction of current flow is going to be like this, going all the way back to this place. So since current is flowing in this direction, when it comes to the resistor, it's going to flow from this side positive to the negative here, from this positive to the negative here, from this positive to the negative here, right? This is very important. So whenever you see questions like this, the first thing to identify is the direction of current flow. So current is flowing from this positive side to this negative side, right? So once you have identified that, then identify the current flow in the resistors themselves. So from positive here to negative, and like that for the entire circuit, right? So now we have this. So now looking at this, now we have to now apply the laws. Now we already established the fact that this is a junction here, right? And we're saying that current is flowing into from this place and is coming out here, and is also coming out through this junction. The junction tells you where the current enters from and where it stops from, because it is here, right? Because this is where we have 2 other resistors. Because it is here, it's telling us that current enters from this side and then it comes out from this side. Alright, so now that is established, we can say that the current that is flowing through the 5 ohm resistor to be I1. Let us now say that the current that is flowing through the 3 ohm resistor to be I2, and the current that is flowing through the 2 ohm resistor, let us say it is I3. Now I've established this fact. Now from the law, it's telling us that the total sum of current that is coming into the junction is equal to the total sum of current that is going out of the junction. That's basically what this means. This E means summation, right? So if there are more than one current entering the junction, addition of everything is equal to the addition of all the current that is going out. Because now from this diagram now, or from this question, we have just one current that is entering into the circuit, and then we have two that are going out, right? So now we're going to say that I1 is equal to I2 plus I3, right? Because this I2 and I3, they are the ones that are going out of the junction, while only I1 is going into the junction. So we're going to say this is our equation 1, right? This one we use Kirchoff's current law, right? We use Kirchoff's current law for this, or the loop law, or the junction law, right? So now, but we have 3 unknowns. So how can we solve this question with 3 unknowns? It is basically impossible for us to solve a question that has 3 unknowns. We have to have 3 equations. Just like when you are solving simultaneous equations, we usually have something like this now. 5a plus 2b is equal to 4, and then we have 3a plus 4b is equal to 5. For us to solve something like this now, we need to have 2 equations because there are 2 unknowns. So then we can solve it. But this one now we have 3 unknowns, so that means we have to have 3 equations to be able to solve 3 unknowns. And very easy, we can do that using, we can get the other 2 equations using Kirchoff's voltage law, which is also known as the loop law. Now for Kirchoff's voltage law, it's telling us that for a particular loop, right? For a particular loop, the sum of all the voltage there should be equal to 0, right? So now for this loop now, we can take from this, if you look at this diagram very well, we have 2 compartments. We have this first box here and we have the second box joined together, right? So we can say that this place here, we can take it to be our first loop, loop 1, and then we take this one to be our second loop, loop 2, right? So whatever we are doing in this box here, this one that we have loop 1 is going to just be only for every component here. So these 3 ohms that is not in loop 1 will not be involved in whatever we are doing for this first loop. So now for loop 1, here we have 12 volts. Basically what we are doing is that we are dealing with voltage now. We are dealing with voltage, right? And we know that V is equal to IR, right? V is equal to IR. So now for this one now we already have our V. Right, for the EMF is 12 volts, but if you look at the EMF, it's going from negative terminal to positive terminal, right? So it's ending on the positive terminal, so which means our voltage is going to be positive. So we're going to be having 12, right? 12. But then do you see the way the loop is going? The loop is going like this, in this direction, right? So that's why it's going from negative to positive. Now we're going to these 5 ohms now. It's going from positive to negative, so it ends on the negative, so which means that our for this resistor, the voltage there is going to be negative. So we're going to say minus, because now V is equals to IR, we have R. The R is what? 5, and the I is what? I1. So it's going to be I1 times 5. So we have minus 5 I1. Then we'll come down to this one. It's coming in this direction, right? So it's coming from positive here to this negative, right? So it's ending on the negative. So we're going to be having negative, but this is 2, and the current there is IT. So we're going to have minus 2 I3, and everything is equal to 0 because this one they cancel out. So let's rewrite this. So we have 12 is equal to 5 I1 plus 2 I3, and this is our equation 2, right? So now we're going to do the same thing for the second loop 2. So now for this loop 2 now, it is going in this direction. You can see that the 2 of them are taking the same direction. Don't use one direction for this one and then you come and reverse the direction for this one. Use the same directions, right? So now it's going like this, the same direction, so it's going upwards. Now this 2 ohm resistor is also in this second loop, so we are still going to use it here. So it's going from negative here to positive, right? That means it's going to be positive. So we have plus 2I3, all right? And then this one is going from positive here to negative here, so it's going to be what? Minus 3I2. But is there any EMF here? There's no EMF, so which means that is all we need. So that is going to be equal to what? 0. It's going to be equal to 0. So let's rewrite this. So we have 2I3 is equal to 3I2, and this is our equation 3. Right? So now I've gotten 3 equations, and now we can now begin to solve because we have all our unknowns and we can solve easily at this point. Let me just clean this off and write our 3 equations up so we have enough space to solve. So now for equation 1, we have I1 to be equal to I2 plus I3. Then for equation 2, we have 12 to be equal to 5 I1 plus 2 I3. And then for equation, so yeah, let me just clean this so that we can have enough space to solve this question. All right, so now we have our three equations. Now we can solve. Now if you look over here, we have 2I3, right, and is equal to 3I2. So let's rewrite this. So we can say 12 is equal to 5I1 plus 3I2, right, plus 2I2. Now from this equation 1, we have I1 is equal to I2 plus I3, right? So now you can say I1 is equal to I2. Okay, I1 equals to I2 plus I3. So let's put it here. So we have 12 to be equal to 5 into the bracket of I1 plus I3 plus 3I2. So we have 12 equal to 5 I. So this supposed to be I2 plus I3. 5I2 plus 5I3, and this is plus 3I2. So we have 12 to be equal to 8I2 then plus 5I3, right? But from here we can say that I3 is equal to 1.5 I2, right? Because if we divide both sides by 2, we have 2, we cancel out 2, so I3 equals to 1.5 I2. So this is going to be 5 into the bracket of 1.5 I3. So we have this. So 12 will be equal to 8 I2 plus 5 times 1.5. So we have 5 times 1.5. So that's 7.5 I3. So let me just write that down. So we have 7.5 I2. Yeah, this supposed to be I2. 7.5 I2. So we have 12 to be equal to 8 plus 7.5 I2. That's 15.5 I2. So now let's get the value for I2. So that means I2 will be equal to 12 over 15.5, and our I2 will be equal to 0.774 ampere. So now I've gotten the value for I2 to be 0.774. So I will say I2 to be 0.774. Now remember that I3 is equal to 1.5 I2. So we're saying I3 is equal to 1.5 multiplied by the value for I2, which is 0.774. So we say I3 to be equal to 1.5 times 0.744, and this gives us 1.161 ampere. So now I've gotten the value for I2 and I3. Now remember that I1 is equal to I2 plus I3. So we're saying I1 is equal to 0.774 plus 1.61. So 1.161. So we have our I1 to be equal to 1.935 ampere. So this is our final answer. Now I found the current passing through each resistor, right? So the current that is passing through the 5 ohm resistor, which is I1, is 1.95, right? And the current that is passing through the 3 ohm resistor, which is I2, is 0.774, and that of the I3 is 1.16. So let's just write that. So we have I1 to be equal to 1.935 ampere, and then we have I2 to be equal to 0.774 ampere, and I3 to be equal to 1.161 ampere. So these are the currents that are passing through each of these resistors. So very, very simple. You can easily get the answers to the questions. Let me just go over a recap. The first thing is to find the direction of current flow, right? Current flows from positive to negative. This is not an electron, it flows from positive to negative. Now, flowing from positive to negative, the next thing is to find the positive part of the resistor and the negative part of the resistors, right? So since current is flowing in this direction, current was flowing in this direction, right? Current was flowing in this direction. So that means that the terminals of the resistor, the positive one will come first before we have the negative one. So the positive to negative. So after you have gotten the positive and negative terminals of each resistor, the next thing to do is to identify the current, right? The current. Now the current that was flowing through here, we said it should be I1 because we don't know it. We have to find it. Then we represent this one with I2 and this one with I3. So after doing that, we now applied our laws. Kirchoff current law, which is alright. So we use then the next thing is to use your laws, Kirchoff current law, which is the junction law, right? Because the current flowing into one junction is equal to the current that's flowing out of the junction, right? The total current flowing in is equal to the total current that is flowing out. Then we use the Kirchoff voltage law to solve this, which is also known as the loop law, because as you can see here, we used these two loops to be able to solve this question. So the two laws are very important in solving questions like this. Alright, so let's look at this question now. So for this question, we are being asked to find the power through each resistor. So I should have written this down. Let me see. Find the power through each resistor. Let me just reduce the text so I can place it well. Well, it is well. Let me just put this here. So now we're finding the power through each resistor, right? So just like in the first diagram, the first thing to do here is to find the direction of current flow. Now, how do we find the direction of current flow? Is to by locating the EMF and the positive terminals of the EMF and the negative one, right? Remember I said that the longer side is the positive terminal, while the shorter side is negative. So for this EMF2, this is positive and this is negative because this place is clearly shorter, right? So now we have this. So now, where is the direction going to flow from? Now, if we are taking from the 3 volts, the current is supposed to flow in this direction, right? It's supposed to flow like this. But when we take from this 1 volt, it is going to flow like this. So now, how do we know which way is going to flow, or is it going to be both of them, right? So now, to know this is just the one that is bigger. The EMF that is bigger will determine the current flow. So since 3 volts is bigger, the current will flow in this direction, regardless that there's another EMF, right? So it's going to flow in this direction. This is how current is going to flow, basically, because this EMF, this 3 volts, is bigger. So now that we have established this, now we'll move to the resistors. So which side is the positive, which side is negative? Current is flowing from this direction to this direction. So this is positive, this is negative, this is positive, this is negative. This current is flowing like this. This is where we have our junction here. So it's flowing like this. So this is positive and this is negative, right? So now we have to find the power. Now we know that power is equal to I square R and is equal to V square over R and is equal to IV, right? And basically, for us to solve this question, we basically need to find our current, because this is the formula we are using, right? We are using this formula because we're dealing with power dissipated. Anytime we're dealing with power dissipated, you're using I square R, right? The power dissipated through each resistor. We're doing I square R. So we need to find I first. But they did not give us the current in the diagram, right? Or in the question. So we need to find I. So we have this I, let's call it I1. The current that is passing through the 4 ohm resistor, let's call it I1. Then the current that is passing through the 2 ohm resistor, let's call it I2. Then the current that is passing through the 5 ohm resistor, let's call it I3. So now we have all these currents. So now we're going to start applying our laws again, right? Kirchoff's current law, KCL. So this one tells us that the current that is flowing through into the junction is equal to the total current that's flowing out of the junction. So now looking at this now, I1 is flowing into the junction, only I1, but I2 and I3 are flowing out. So we can say that I1 is equal to I2 plus I3. This one is equation 1, right? So now we need 2 other equations which we will get from our loops, right? Using the Kirchoff voltage law, which is also known as the loop law. So we'll be having the first loop, loop 1, and then we have our second loop here, loop 2. Right, this one is more interesting because here we have 2 voltage, whereas in the first one we had just 1. So you can pause the video at this point to try out the question using the same idea that we had in the first one, and it should work for this. Alright, so let's go. So here now we are moving like this. This is the direction in which we are moving, like this. So it's going from negative here to positive. So it means our voltage is going to be what? Positive, because it ends at the positive side. So we have 3, right? Then when we come to this 4 ohm resistor, it's coming like this. like this. So we have from the positive to the negative, so it's going to be what? Negative 4I1, right? Because don't forget that our V is equal to IR and we're dealing with voltage here, but since the voltage is not particularly specified, our I is also not given, so we just use the I and multiply by the resistance, right? The current is I1 multiplied by the resistance, which is 4 ohms. So now we're also moving in this direction, which is the 5. This 2 is not in this first loop. The first loop only encompasses this box here, right? So it's not in the first loop, so it is not going to be part of this first loop, right? So now here we're moving in this direction, which is all right. So we have this, sorry. Alright, so we have this 3 minus 4I1 minus 5I3 is going to be equal to 0. So let's rewrite this. So we have 3 is equal to 4I1 plus 5I3. So this one is our equation 2. So now let's go to the second loop. Now for the second loop, it is going in this direction, upwards, right? So it's going from negative here to positive here. So that means we're going to be having positive 5I3. Then it's going in this direction, which is from positive to negative, so we're going to be having minus 2I2, and here it's coming down, so it's going from positive here to negative here, which is going to be negative 1, and this is going to be equal to 0. So let's rewrite this. So we say 1 is equal to 5I3 minus 2I2, and this is our equation 3. So let me just write this out. I2 plus I3, then we have 3 is equal to 4I1 plus 5I3, then we have 1 is equal to 5I3 minus 2I2. So let me rub this off so that we have enough canvas to solve the question. All right, so now from this one, now we have 5I3, we have these two. So now what we're going to do here now to make it easier for us is to put this I1, put it here, so that everything that we have will just be I2 and I3, and then we'll just solve it using simultaneous equation, either by substitution or by elimination method. So we have 3 is equal to 4. I1 is what? I2 plus I3, then we have plus 5I3. Right, so we have 3 is equal to 4I2 plus 4I3 plus 5I3. Then 3 is equal to 4. Okay, let me put the 9 in front. Right, so we have 9I3 plus 4I2. Then we're going to bring this other equation. So we have 1 is equal to 5I3 minus 2I2. So now we have these two equations, and then we can solve it using either elimination or substitution. But I'm using elimination because I think it is faster. So we'll multiply this one that is up, we multiply it by 2, and then we'll multiply this one down, we'll multiply it by 4. Multiply it by minus 2 and this one by 4. So here we're going to be having minus 6 is equal to minus 18I3 minus 8I2. Then one for the bottom, we have 4 is equal to 20I3 minus 8I2, right? And here we're going to be adding them. So adding them now, minus 6 plus 4 will give us minus 2, and it's going to be equal to minus 18 plus 20 is going to give us minus 2I3, and then we have minus 8I2 plus minus, okay, so we're supposed to subtract, sorry, so we're meant to be subtracting. All right, so here we're going to subtract. So subtracting now, we have minus 6 minus 4, so that's going to give us minus 10, and it's going to be equal to minus 18 minus 20 is going to be minus 38I3. Then we have minus 8 minus 8I2, which is going to be minus 8 plus 8I2, which is going to be 0, right? So here we have minus 38I3 is equal to minus 10. The negative sign we cancel each other, so we have I3 to be equal to 10 over 38. So I3 to be equal to 10 divided by 38, and then we have I3 to be 0.263 amperes, right? So now I've gotten the value for I3, and then since we already have this equation here that I1 is equals to 5I3 minus 2I2, we can easily solve and get our value for I2, right? So this is what we're going to do now. We're going to look for I2. Then after we find I2, use those values to find I1. So now we are saying that 1 is equal to 5I3, and I3 is 0.263 minus 2I2. So 1 is equal to 5 times 0.263. That gives us, so we have 1.315 minus. Alright, so we have 1 to be equal to 1.315 minus 2I2. So I'm making 2I2 solve all the formulas. So we have minus 2I2 to be equal to 1 minus 1.315. So doing that, we have 0.31. So we have minus 2I2 to be equal to minus 0.315. Then we'll divide both sides by minus 2. The negative will cancel out. So we have I2 to be equal to 0.315 divided by 2, and that gives us 0.1575, which is approximately 0.16. So we have that, and then the next thing is to find our I1. Now we already have I2, so let me just put it here. So I2 is equal to 0.156 ampere. So now we're going to be looking for I1 now, because we already have this one. Remember, we're looking for power, not just current. So finding current is the first step in the right direction. So now our current I1 is equal to I2 plus I3, and this is equal to 0.156 plus 0.263, and this gives us 0.42 ampere. So our I1 is equal to 0.42 ampere. So now we're going to find our power, right? So I'm going to say P1 to represent the power that is dissipated in the first resistor, which is the 4 ohm resistor, is equal to I1 square multiplied by R1. Then P2 will be equal to I2 square multiplied by R2. Then we have P3 I3 square multiplied by R3. So our I1 is what, 0.42 squared multiplied by I1, which is the 4 ohm resistor, and this is equal to, then we have the I2, which is 0.156 squared multiplied by the 2 ohm resistor, and then the last one we have the 0.263 squared multiplied by the 5 ohms resistor. So you can go ahead and put your calculator. So we have 0.42 squared multiplied by 4, and this gives us 0.71 watts, because we're dealing with power now. So we have 0.156 squared multiplied by 2, and we have 0.05 watts, and then the last one we have 0.263 squared multiplied by 5, and we have 0.34, let's say 0.35 watts. So this is the power dissipated in each resistor, the 4 ohm resistor, the 2 ohm resistor, and the 5 ohm resistor respectively. So it's very, very easy. Just a quick recap. The first thing, to find the direction of current flow. Once you have 2 or more than 1 EMF, you should use the biggest EMF or the biggest power source is going to determine the current flow. So for this question, 3 was bigger than 1, so the current flow was determined by the 3 volts EMF, which was in this direction, right? And we said that the shorter side represents the negative terminal, while the longer one represents the positive terminal. So now, knowing that, the next thing is to find the terminals of the resistor, the positive and negative terminals of the resistor. Then we move over to our Kirchoff's current law, which tells us that the total current that is coming into the system is equal to the total current that is going out through the junction, not the system, sorry, the junction, right? And we already identified the junction to be this point here. So identifying that, we found out that I1 was equal to I2 plus I3. Then we found our 2 other equations, because we need 3 equations to solve this question. and then we found those two other equations using Kirchoff's voltage rule, which is also the loop rule. That's why we use loops here, the loop 1 and loop 2. The direction is very important. They must go in the same direction, right? So that being said, we drafted out our two equations, we solved it simultaneously, and then we were able to get our currents, right? Because we needed current to be able to find power. Remember, there are more than one formulas for power, right? Even more than this, but the one related to electricity is basically these three, right? Basically these three. And then for power dissipated, we are using this one, right? Power dissipated, we are using I square R. So we needed to find current, so we found all the three currents, I1, I2 and I3, right? And then after finding we use our formula and then we solve, right? So don't make the mistake and don't use a resistor. Like for this one now, R1, just because you got the current correctly and then you now use 2 ohms instead of the 4, you will get it wrong, right? Because that 2 ohms is for the I2 current. So it's very important that you. Alright guys, so this question now, the question says find the current flowing through the ammeter. Alright, and already this component here that has letter A is representing the ammeter. So I'll find the current that is flowing through this ammeter. Now this question is not particularly about the current that is flowing through the resistors or each of the resistors or the total current in the system. It's just particular about the current flowing through this ammeter. Alright, so I'm not going to solve this question all through, right? But I'm going to explain basically what you need to do, and then you solve and you get back to me. So basically, first thing is to find the direction of current flow, right? This side is longer, positive, this side negative. So current is flowing in this direction, right? Current is flowing in this direction. Right. So now for this question now, we have 3 resistors, and this one current is also flowing like this because this is where our junction is. So current is flowing like this. So this is our positive, our negative, our positive, our negative, and this is our positive and this is our negative. So now we have all this. Well, this is where current 1 is. Let's say that's our first current. Then let's say the current that flows here is the second current, and now let's say the current that flows here is I3. So now what you need to understand is that the current that flows through this 6 ohms resistor is the same current that flows through the ammeter. So if we find this current I3, it means that we have found the current that is flowing through the ammeter, right? Because if you see here, there is no junction here, right? So it means that there is no cut of current. So the same current that is flowing through this direction here is the same current that flows like this, the same exact current. So if I3 is flowing like this, it means that I3 is the same current that flows like this. I hope that's clear, right? So for this one now so this resistor here now, we're going to say is the current that flows through it is I4. Well, now what you need to understand is that these two, this I1, right, this current I1 and this current I4, they are equal. I1 is equal to I4. Now the reason is because I1 and I4, they are in parallel. So like the same current. Now if there was a resistor at this junction, the same current that will flow through this resistor will be the same current that will flow through this resistor, right? So for that reason, the current that flows through here is the same current that flows through here, right? So we're saying here that I1 is equal to this I2 that's going out plus this I3, because this one is also going out, right? So this is our equation 1, right? So now we're going to take our loops. So the loop 1 and we're going to take loop 2. All right, so I'm going to stop here. So you complete the loop, get the other two equations, solve and find the current that's flowing through the ammeter. So once you are done, you can snap your solutions and then forward it to me. My WhatsApp number is on the screen, right? It's on the screen. 08156909935. So send your solutions to me. Solutions is important so that not just the answer. So if peradventure you make a mistake, I can point out where exactly you made the mistake.